Okay, hello, I'm Eric, and today I want to talk to you about a project of mine that I've been very excited about for the last few years, and finally able to present because, yeah, I got a working prototype now. So let's get into it. When we're talking about Bitcoin privacy, there are. Is it working? Okay. When we're talking about Bitcoin privacy enhancing technologies, then there's a fundamental difference between like on which layer they operate. We have the layer 1 technologies like coin joins, pay joins, tumbling. They're all great, but the problem is we know blockchains don't scale. And that means that layer 1 privacy will never be something that most people are able to use, because most people are probably not going to spend extra money on on-chain transactions. So we have to find a way to bring privacy to people in ways that are actually cheaper, more convenient. And we are already seeing this happening with layer 2, like Lightning, Liquid, and some other protocols that have been proposed. And today I want to talk about Lightning. So when we are thinking about Lightning wallets, there are a few dimensions on which different implementations of wallets differ. Like we all know that there are self-custody wallets and third-party custody wallets. But there's also a distinction to be made between self-hostable and proprietary wallets. And finally, of course, also private and less private means of doing Lightning transactions. So all of us probably know we can host our own Lightning nodes like C-Lightning, LND, Eclair. They provide pretty good privacy. Like it's not perfect, channel probing exists, but they are self-custodial, so you're fully sovereign. They're self-hostable and privacy is okay. But over the years we have seen that people don't really want to like take care of their own channels, and so many that want to use Lightning nonetheless have chosen custodial solutions, proprietary custodial solutions, for example like Wallet of Satoshi or others, that like where they just trust some service provider that happens to have built a wallet. And I don't think that we as Bitcoiners want such a future where people just trust random people that happen to have built a wallet. That's just like banking built on Bitcoin, and in a bad way. So more recent efforts have been going into the direction that you can self-host your bank, like hosted channels and LN bits. That has the big benefit of, let's imagine I have a friend and want to bring him to this conference. And he doesn't have a Lightning node, but he really wants to pay with Lightning. Then I can just set him up with me as his Lightning service provider. And because he trusts me, I'm his friend after all. So that's kind of okay, because there is a natural trust relationship between us. And that's a big improvement in my opinion. But the problem is still, if you were to scale this to a level where he had to store a lot of his net worth with me, then I'd have an outsized control over him, which isn't good. For example, if we had a falling out, I could just take his money. So Galore is already going into the right direction by positioning itself as a self-hostable semi-custodial wallet. Because why do I call it semi-custodial? Because the funds are mostly held in a multi-sig wallet. Like there's no single point of failure. You can choose a set of people you trust that as long as they don't all conspire against you, your funds are safe. So that's a big improvement. And what I'm proposing today is adding privacy to this model, because Galore is great, but you probably don't want your neighbor to know how much you own. And that's exactly where Federated E-Cash comes in. So when I talk about Federated E-Cash, I will be referring to Minimint, which is my implementation of it. There are other implementations and other possible choices when it comes to some technical details, so bear with me if like there's something you could do differently. That's probably just like a design decision on my side. We can probably come to it during the questions. Yeah, but I'm talking about federated eCash, and most of you probably don't even know what eCash is. So we should start with what is traditional Chaum eCash. As it says there, eCash was invented by David Chaum in the 80s, and it's a way to transfer value, to have an electronic cash system that is fully anonymous. So that makes it very interesting because as Bitcoiners, we want privacy. And these Chaum eCash systems had perfect privacy. And how did they do it? Using blind signatures. I think I first have to explain what blind signatures are for you to understand what an eCash scheme is. So blind signatures, if a blind signature scheme allows a user to acquire a signature on a message without the signer ever learning the message. And we can imagine it as follows. The user chooses a message that they want to be signed. Then they blind it using a blinding key, which leaves them with a blinded message. They can give this blinded message to the signer. The signer can then generate a blind signature from this blinded message using the signing key, give this back to the user, and finally the user can unblind the signature. And they're left with a valid signature for their message. But the signer never learns the original message, nor the signature the user in the end receives, because the blinding key decorrelates these both sides. And you might be wondering, why would anyone ever sign something they haven't seen? Like you wouldn't sign a contract that you haven't read. But with eCash, we can use such a primitive to construct something very beautiful. Because what we do is we say every message signature pair has a certain value. Let's assume value of 1 Bitcoin per message signature pair. What we can then do is we, as a user who wants to deposit money to an eCash mint, we can just generate, let's say, 2 random messages, 2 nonces, because the only nonce means number only used once. And the only requirement we have for this nonce is that, yeah, it's a unique message. And we can essentially just draw it randomly. And now we have these nonces and can blind them. And if we give 2 Bitcoin and 2 blinded nonces to the mint, then the mint will just take the Bitcoin and put it into their collateral storage. And because the mint now knows they have 2 Bitcoin, they will also generate 2 blind signatures for us. And we as user can then take the blind signatures and unblind them. And what we are left with is 2 nonce signature pairs. As I said, each message signature pair has a certain value. In our case, let's say 1 Bitcoin. And so now we have a representation, an IOU of these Bitcoins. But since the signing process was blind, the bank cannot correlate when it sees the message signature pair again. It cannot correlate when it actually signed it or to whom it issued it. And that's a really strong privacy property we get there. And let's say I want to spend such a token. Then imagine I want to pay Bob 1 Bitcoin in eCash. Then I take one of these message signature pairs and just give it to Bob. It's just data. I can send it over Telegram, whatever. And what Bob then has to do is he has to go to the mint to ask if it was already spent, because we still have the double spend problem as we have in Bitcoin. And, but the mint is a centralized entity, so it can look into its ledger and see if there was a double spend. And if not, Bob can again generate a nonce, blind it, send the blinded nonce and the message signature pair to the mint, and the mint will sign a new the new nonce, and Bob has a completely different, new message signature pair that they now can use as money as well. I wrote there that it could also be a Bitcoin address that you give to the mint, because essentially you could also just tell the mint, please send me the Bitcoin on-chain somewhere. Like that works as well. Like instead of staying inside the mint, we could also just like go on-chain again. So we already see the pros of this. It has theoretically perfect anonymity. Why theoretically? Because like implementations always need to make trade-offs. And one of these is if we want to have fine granular amounts, then ideally we would set the amount represented by one token to one Satoshi. But the problem is then we need to issue really many of such tokens. And well, that would become pretty slow and cumbersome. So what you typically do is you introduce amount tiers, like one signing key represents 1 Satoshi, another represents 10 Satoshi, yet another one represents 100 Satoshi. So you split your anonymity sets. It's still perfectly private in each anonymity set. If you combine them to pay a specific amount, it's a little bit more complicated. But it's still super, super private compared to anything else we have in Bitcoin today. And it's also scalable because user only really cares about their own tokens, and they don't have to keep track of a chain or anything like that. And the mint essentially can just throw compute resources at a problem. Like if they need to process more transactions, they can just spin up more servers. That's pretty easy. So, but there are also downsides to it. Firstly, why was it never adopted really? It's centralized and can easily be shut down. And governments generally don't really like you to have anonymity when it comes to finance. So both the token issuance and the collateral storage have to be centralized. For the token issuance, there has been a proposal already in the early 2000s, I think, to decentralize it. But back then, they didn't have the means to also decentralize the collateral storage, which we now have with Bitcoin, because we have multi-sig wallets. And there's also no cross-mint, there are also no cross-mint transactions, which can be a problem, because then everyone has to be on the same mint, and it's not easily auditable with the basic traditional Chaum eCash. And what I'm claiming is that we can pretty much solve these first two problems with federated Chaum eCash, with Lightning integration. But first to the centralization issue. What can we do about it? And dare say, federations to the rescue. Because any centralized protocol can be converted to a federated one given some fancy cryptography and the consensus algorithm. So now instead of trusting one party completely, we can trust T of n parties to not collude, which is a totally different trust model from what we had before. Like imagine in your village, you maybe have 4 people who need some money. And if he was the only holder of the keys, then he might still decide to just take the money and burn his reputation. But if you have this 3 or 4 federation, then he had to convince 2 other people to conspire with him to actually get the money. And that makes it so much more secure in my opinion. And it's also a great design decision already taken by Galore. And with federations, we can take it a bit further by automating the process. Like they have a manual multi-sig wallet, as I heard. And with federations, you can totally automate it because there are just rules under which funds can move. So how do we implement the federation? The token issuance goes from using blind signatures to threshold blind signatures, which is essentially just a cryptographer term for, like now we need T of n parties to collaborate to generate blind signatures instead of only one. And for collateral storage, we can just use plain old Bitcoin multisig. We can essentially view the federated eCash as a replicated state machine where all the state transitions have to be agreed upon using a consensus algorithm which runs between all these participants. And state transitions, you can think of that as transactions essentially. They have to agree on the order of transactions, just like in Bitcoin, but they do it using BFT consensus algorithm. That's some old tech developed also in the 80s and 90s. that has a fixed set of members that run this consensus, and then you get a list of transactions that happen. Then you can process them in a deterministic way. Let's say you have a transaction that spends eCash tokens and sends Bitcoin on-chain. Then you give the spending part to your eCash Mint module and the on-chain part to your wallet module. And since they are deterministic, your federation afterwards should be, every federation member should be in the same state. And so they can never diverge and have always consensus over who owns what, yeah, and so on. So now that we have solved the centralization problem, there's really only two problems left: the cross-mint transactions and the auditability. Auditability, we can't really do much about it. I thought about it, and essentially what you get when you introduce auditability to federated eCash, then you get federated zero coin, Zcash, stuff like that. So we don't do that. But we can solve the cross-mint transaction problem using Lightning, because by integrating Lightning into federated eCash, we essentially get fully anonymous semi-custodial Lightning wallets. And we have a few ways to do this, actually. How do we integrate Lightning? There's the first version, having a fully trusted Lightning gateway. That's obviously lame. We don't want this. Like, we have worked so hard to have a federated trust model where you only have to trust T of n parties. And now we want to give it away to have Lightning integration? No, that's not what we want. There's a second version where we have smart contracts inside the federation that allow you to conditionally pay the Lightning gateway. And the holy grail of Lightning integration would be a federated Lightning node, which essentially runs on top of the consensus on all the federation members' nodes. But we are years away from that, so we will not talk about this. But I can explain to you in a minute how does the integration using smart contracts work. First, let's have a look at version 1, where you just pay the gateway, and the gateway then starts the transaction for you, tries to pay your invoice. But you have to really trust the gateway, because you pay the gateway first, and then you hope that it actually pays your invoice. And that's not a good trust model. You shouldn't do this. So instead, let's think about how does a Lightning transaction work. In every invoice, there's actually something called a payment hash. And the payment hash is used to establish a route consisting of HTLCs, hash time lock contracts, going from your payer to your payee. And your recipient of your transfer can only receive their money if they can give you the pre-image to set payment hash. And this pre-image then travels back the route. And so in theory, and also in practice, the Lightning gateway should receive the pre-image to every payment hash for every invoice they paid. So what we can do with this is we can make the payment of the Lightning gateway conditional on the Lightning gateway being able to present this pre-image. And we can also add a time lock, because we don't want to indefinitely lock our funds. So we say, as a user, I lock some funds in the federation with the federated trust model in an account inside the federation. And the Lightning gateway can only take them out of it if it can present a pre-image and if a time lock hasn't expired. After the time lock expires, the user can just take the funds back. And so we essentially extend the Lightning network into the realm of our federation, which makes this whole operation trustless and atomic. So the Lightning gateway has to trust the federation, and the sender also trusts the federation, but we are all operating inside the federated trust model, which is great. So what this gives us is a federation of federations. We can now, every federation can now interact with every other federation and every other Lightning node on the network. So there's no centralization pressure. It doesn't matter if I'm in the Cypherpunk Federation and you're in the El Salvadorian Federation. That's not a problem. I can just route to you over the Lightning network. And also if some sovereign individual runs their own Lightning node, I can also send payments to them or receive payments from them. So that makes it a powerful tool to scale Bitcoin and make it more private, because for privacy to become widespread, it has to be convenient. And we have seen people really like custodial solutions, and we don't want them to use custodial solutions, so we have to find a middle ground. And I think Federated E-Cash with Lightning integration is such a middle ground that we can use to make Bitcoin more private, make it more scalable, and still have trust minimization, which is a core goal of Bitcoin, in my opinion. So that's about it, and I'm happy to take questions if there's time left. Thank you. Yeah, can you get a mic? Or yeah, no.
No, I'll start.
Oh, okay.
One question here. So Minimint, you mentioned at the beginning. What's the current status of that? Can we use that right now?
No, unfortunately not. Like Minimint is still in a proof of concept stage, and I'm kind of the only developer working on it right now. Also, I've already received some interest in other people to join, and I really hope that this will work out, because this will really push it forward. Right now, please don't use it on mainnet. Play around with it on Rectest. That's a great way to get into it. Yeah, but it's probably around a year away from like being able to have a reckless version on mainnet.
Thank you for the presentation. I have a question with regard to the version 2 Lightning integration. So you will have the sender generate the preimage to give for the payment hash, and say how would they choose and check the time lock?
I mean, in the outgoing version, the recipient generates the preimage.
Yeah, right. So you would send it to the sender, but he needs to pay only if the time lock hasn't expired, right?
Yeah, like the sender would have to use the timeout from the invoice, in my opinion, to create this contract.
Yeah, so yeah, no.
Yeah, it should be in the invoice, I think, the timeout.
Yeah, an invoice, but it was with regard to checking the time lock on the blockchain, so you will need access to a node.
Oh, right. That's an interesting point. Like the Federation has to have agreement on what the block height is. So that's how we would like enforce it. The Federation would have like this internal consensus where all the members contribute what they see as the current block height, and that's how you also do the time lock inside the Federation.
Thank you.
Any more questions?
Just thank you for the presentation. Really good. I'd like to ask about the denominations of the eCash nodes. That you mentioned that the ideal would be to have like one Satoshi nodes, but then, I mean, it depends what. Would it depend rather on the value of Bitcoin and, you know, how much purchasing value people would use? So like at the current state, you know, you would want to do like $1 denominations, 1, 5, 10 or so. So that would be like 2,000, you know, 5,000, 10,000 Satoshis or so. So what would be the ideal, would the ideal amounts be like the 1, 10 and 100 you mentioned, or would it be a bit higher now?
Like that's a trade-off. Like generally you would use the powers of some base. Like you could do 2 to the power of X or 10 to the power of X. And that's essentially a trade-off in how many tokens do you need to represent any amount. Like the maximum or the average number you need to represent any amount. And your anonymity set per amount tier. So if I do the 2 to the power of X tiers, then I obviously have many more tiers. So each tier has a smaller anonymity set. But also, I have an upper bound of, I think, the logarithm to the power of 2 of the amount I want to pay, that I need, like the number of tokens that I need to represent that amount. While if I have 10 to the power of x as tokens, then this minimum, this average number of tokens I need to represent that grows. And yeah, that's just a trade-off. And ideally, in the future, we could have like arbitrary amount tokens using some blind value scheme that we can discuss like off the record. But yeah, that's really a researchy thing right now, and I don't think I need to explain this here. So.
Okay, thanks, elsirion.